Welcome back, everybody. Today we're going to talk about writing and graphing inequalities. Let's talk about inequalities. An inequality is a mathematical sentence that compares expressions. Our inequality symbols are less than, greater than, less than or equal to. Remember, it changes because of the little line underneath there. And greater than or equal to. Some key phrases that allow us to know which one of these that we're using when we're reading a problem would be is less than, is fewer than. Our next symbol is greater than, is more than. Our next one is less than or equal to, is at most, is no more than. And then this last one is greater than or equal to, is at least, is no less than. So those are the key phrases that are going to clue us in for what type of inequality we should use when we're writing our expressions. A number W. So I'm going to start with this, a number W minus 3.5 is less than or equal to. So if we look up at the chart we just made, is less than or equal to, has this inequality symbol, and then -2. And so we wrote it as a sentence. Number 2, 3 is less than, so that's the symbol, a number n plus 5. Our third example, change colors here, 0 is greater than or equal to, so we have this symbol. Twice means multiplying by 2 a number x plus 1. So 0 is greater than or equal to 2x plus 1. You try the next two. All right, checking solutions. So what is the solution of an inequality? It's still a value that makes the inequality true. It's just that inequalities can have solution sets. So a solution set is the set of all solutions or possible answers of an inequality. So let's look at this table of examples. If I'm looking at this table of examples, it's asking us to start with -6. So is -6 a solution of this? Well, remember we replace x with -6, so -6 plus 5 is greater than or equal to -2, which -1 is greater than or equal to -2. Is that true? Yes. So -6 is part of our solution set to this inequality. Now we plug in -7. So -7 plus 5 is greater than or equal to -2. -7 plus 5 is -2. Is -2 greater than or equal to -2? Well, -2 is not greater than -2, but it is equal to. So yes, that would be part of our solution. Let's plug in -8. So we have -8 plus 5 is greater than or equal to -2. -8 plus 5 is -3. So is -3 greater than or equal to -2? And the answer to that is no. So 6 and 7 would be part of our solution set, and 8 would not be. Tell whether -4 is a solution of each inequality. For number 6, we would start with subtracting 8 from both sides if we were solving. And then we could see that way. The other method that we could do is to just plug in -4 for the variable and see if that's true. -4 plus 8 is +4. Is +4 less than -3? And the answer to that would be no, it is not. So not a solution. If I look at number 7, again, this is multiplying. The opposite of multiplying is dividing. I don't think we're going to go that route just yet, so let's plug in that -4 for x. So is -4.5 times -4 greater than -21? Well, -4.5 times -4 is +18. Is +18 greater than -21? Yes. So this is the solution there. All right. If you have an even hour class with me, do the even numbers from 8 to 11. If you have an odd hour class with me, do the odd values of 8 through 11. Graphing an inequality. So what are we graphing if somebody were to say, graph the inequalities? We are graphing the solution set of the inequality on a number line. Line. When do we use closed circles? This is the key part right there, closed circles. We used closed circles when a number is a solution, when we have less than or equal to and greater than or equal to. So that means the answer that we get is part of our solution. Versus closed circles, open circles from closed circles. So open circles are when the answer that you get is not a solution, but starts the solution set. If you're looking at the symbols themselves, then it would be when we have less than or greater than. So closed circles are when they're equal to, open circles are when they're not equal to. Let's look at graphing some examples. So for your number line, we don't need the super long set of numbers. I usually say at least 3 so that we know that you know the direction that things are going on that. So if y is less than or equal to -3, equal to means this is a closed circle, and less than is -infinity. So we would shade to the left. It also works to say that the inequality is going to the left, so we're shading to the left. But that only works when your variable is on the left side. So knowing that, if I'm looking at number 13, remember I can pick this up and flip it over as long as the inequality is still facing the same direction, meaning the mouth part's over here at x. So the mouth part is at x here. I haven't changed this answer. I've just rewritten it so that the variable is on the left. Now that we know that our variable is on the left, here's my 3 numbers. Open circle at 2 because it's not equal to, and then greater than means we're going to positive infinity and we're shading on the right. (14) x is greater than 0. The x is on the left side, so I'm not worried about changing things around. Have our number line, -1, 0, 1. This is an open circle at 0 because our inequality is not equal to. And then we're shading over here towards positive infinity. For the U try in 15 to 18, even hours do the even numbers, odd hours do the odd numbers. Writing linear inequalities from graphs. So we have that problem that we will do in class together. And our last part is our summary. So in our summary, in words, if we have x Oops, sorry about that. X is less than 2. In algebra, that's going to look like this. And on a graph, we're going to have an open circle at 2. Less than is going to negative infinity. X is greater than 2. In algebra looks like this. And on our graph, open circle at 2 again, and now we're going to the right at positive infinity for greater than. X is less than or equal to 2. The algebra looks like this. And on our number line, we have now a closed circle at 2 because it's equal to. And then we're going to negative infinity on the left. And last but not least, X is greater than or equal to 2, which will look like this. And then our number line. And we will have, well, let's use blue, a closed circle again at 2 because of the equal to. And we're shading to positive infinity. Nice job, everybody. Thank you very much. Have a good rest of your night. We'll see you next class.